problem, we are given an array and our task is to find the peak element. So a peak element is an element that is greater than the neighboring element. And the interesting part of this problem is that we have to solve it efficiently and better than simple like a linear scanning, going to search the highest element, searching. So how we can solve it efficiently without like doing a linear scan or linear search in it. So an element is considered to be peak if it's greater than its both left and right of the neighbors. For a boundary element, we can only compare the available neighbors. Like the like if the first point, like if the if it has a like if zeroth position, it doesn't have the neighbor on the left hand side, and if at the end of the position it doesn't have the neighbor on the right hand side. The problem guarantees that at least one peak always exists in the array. So what we're gonna do, we're gonna use the binary search here. Even though the array is not sorted, we can still use binary search logic. If element is smaller than its next element, that means the peak element must exist on the right side. And if the element is greater than its next element, then the peak element on the left hand side or at the current position. So if you can see, we have applied the binary search logic here in the function, and let's go through the code walkthrough. I will start by initializing the left index at 0 and right at the last of the array. Inside the loop, I calculate the middle index. Now I compare the middle index with the next to it. If the middle element is smaller than the next one, it means that we are an increasing slope. So we peak must exist on the right hand side. Otherwise, we are on the decreasing slope. It must exist on the left hand side or at the current index. We are keep narrowing the search until left and right point to the same index. So if we have, suppose if we have array of like 1, 2, 3, 2, we can clearly see that the third is the peak of the index. So if we apply the logic like left is 0, right is 3, and mid is equal to 1, when the number of index at 1 is 2 and number of index is 2 is 3, so 2 is greater than 3, move left to mid plus 1 and left is equal to 2. Then when left is 2, right is 3, we will do like mid is equal to 2, where number of like index at 2 is 3 and index at 3 is 1. When we compare that the 3 is greater than 1, we move to the right to the mid and right is equal to 2. Then when left is equal to right is equal to 2, we stop the loop, come out of the loop, and we return the peak in element index is equal to 2 and peak element value is 3. So at every step we discard the half of the value of array. Since the array always contain at least one peak, we never lose the correct answer. So our time complexity is O of log of n because we are divided the search space by half of its every iteration by using binary search. And our time complexity is O of 1 because we are not using any extra memory and we are using the just searching algorithm to just finding the peak element in the array. Let's also try run this solution. Here we can see the peak element index is 2, that is 3.